probably seen this. I love this demo. It's really, really simple, but it's kind of beautiful in a bunch of ways. This shows off sort of what the next generation of the web looks like. It's interactive 3D content rendered in the browser. You can see it here on my code pen. There's no magic going on. It's literally just JavaScript and HTML. I have a 3D scan of this guy. He's the CEO of a small agency in Venice Beach. We 3D scanned him in a T-pose, attached an animation to him, put some JavaScript around it and CSS, but there's a little button there, and when I click it, he animates. And so, this is a really nice stress reliever. I can do this all day long. So that's my talk today. I'm going to talk to you guys about interactive 3D on the web. This is literally a canvas running some JavaScript code that uses the graphics card in your machine. And so, of course, we're using 3JS. I'm sure you guys most of you have seen some 3JS code. You've probably had a 3JS talk. This is not going to be a 3JS talk. I'm actually going to step back a little bit, and what I really want to introduce you to in just the 15 or 20 minutes that I have is a couple of the design patterns that game developers and interactive developers use, and ways to sort of think about building applications that you might use in a variety of things that you build, whether it's guys getting kicked in the nuts, or interactive product presentations, walkthroughs, architectural modeling. Whatever industry you're in, eventually that content is going to make itself to, it's going to start moving towards more interactive content. And these are some of the design patterns you want to look at. So I'm going to talk to you about the component entity system pattern, basically composition over inheritance. I'm going to talk to you about scene graphs. Really, really simple, and it's almost embarrassing to talk about it, but they're used by pretty much every rendering engine, every game engine, so we're just very quickly talking about what the scene graph is. And then, with whatever time I have left, I'm going to walk you through some 3D assets and how that works, just to demystify it. People get really scared when they see 3D content, but it's really not that bad. Now, of course, before I get into that, I'm going to do the obligatory marketing spiel and why I'm here. And fundamentally, I believe that interactive 3D is the next big data type on the web. It's web started as text, hyperlinks, we have images, and then most recently audio and video. And if you look at video, you see you kind of look back at video and see where I'm going. Anybody who's my age, or about my age or older, you're going to recognize this. It used to be, if you wanted to play video in the browser, you needed a plugin. You needed a QuickTime player, or you needed a Flash player, or something in your browser. You weren't actually, the browser itself wasn't running the video. You needed this technology to be able to make anything play. And it wasn't just that. Producing video 20 years ago was really hard. The tools to make it were hard. You needed experts. And then delivering that content, you had no YouTube and you had no HTML5. Of course, now we have HTML5, so video is mostly solved. 3D is in the same state. 3D is like, a few years behind video. If you've seen 3D on the web, it's probably some crappy Java applet on a museum website, some really ugly piece of crap thing that makes you embarrassed that the designer who built it. You might have seen some Flash 3D, some like, interactive car configurator or something. And you've probably seen a lot of Unity. Definitely in the app space, building games with Unity. I mean, it's awesome. But when you take that stuff to the browser and you put it in a box, it sucks just the way that QuickTime used to suck with video. But just like HTML5 gets us video in the browser, WebGL gets us 3D in the browser. And even more important, I'm going to skip, I'm going to talk about this. Okay, so just like HTML5 gets us video in the browser, WebGL gets us 3D in the browser. And this is kind of not an entirely correct diagram, but basically the idea being, forget plugins, that's not going away anyway. But what your web app is getting access to today that it didn't have access to even 6 months ago in some cases, is a direct connection down to the drivers and the operating system of your device. Whether that's graphics card through WebGL, or multi-threading through workers, or video and audio support, like the browser is giving you closer and closer access to the hardware of your device to give you the kind of performance that you used to need an app to get. And this is all being opened up to you today. And these are all standards and APIs that you should start playing with because they're really fun. So you got graphics, WebGL, processing, workers and scripting, web audio, web video, WebRTC, web, lots of stuff. Okay. I'm just talking really fast because I only have a few minutes, so I'm going to slow down a bit because I'm going to start freaking myself out. Okay, last point before I get into the real what I want to talk to you about today is The reason why this really matters, if you look at the line here, this is our mobile graphics cards. The graphics card in your phone today is pretty much as powerful as a previous generation game console. And with WebGL, you get access to that. So you get access to all this performance and capability in the browser on your phone, on pretty well any device, but especially on the phone where you need it. You have access to this power if you just use it. So not that we're all going to go out and become graphics developers, but just to say, if you start to use middleware and tools that give you access to those capabilities, you can do a lot more than you ever could before. Okay, so now that's my spiel, marketing piece out of the way. Now to kind of the design patterns that I want you to take away from this. The first one is the component entity system pattern. And so if you think about any video game, say Super Mario Brothers, if you approach this the way a normal developer would approach this, you think about this from an object-oriented systems perspective, you start to look at this and say, okay, what are the objects that I have? I've got Mario, I've got the turtle, I've got some bricks, I've got the pipes, I've got all these objects. And then start breaking that down into inheritance hierarchy and saying, okay, well, the turtle and Mario, they both move side to side, so let's put that up in the parent class and the subclass. And you say, well, some of these other objects, like, you start building those inheritance hierarchies, and you say, well, I want actually collisions to affect the bricks and the pipes. And you start, over time, you end up building up these really messy object hierarchies. It just doesn't work. And in an interactive scene like this, where you've basically got to draw the page based on all kinds of different things that could happen, all kinds of interactivity that could happen, the inheritance model fundamentally breaks down. And so the way that typically that gets solved in a rendering engine or a game engine is you look at instead of inheritance, you look at composition. So you're basically decorating objects instead of inheriting from superclasses. And so the pattern that's often used here, and it's worth kind of just, again, it's just a different way of looking at things and building things. But you basically break those objects down to being nothing but a unique ID. So Mario fundamentally is just a unique ID. And then you start decorating that. You say, well, Mario's got a translation. He's got a location in 3D space, a rotation, a scale. And those just become decorations. And everything's a decoration. Like the way that he interacts with the camera, the way that he interacts with controllers, the way he moves, the way he dies, everything becomes a decoration. So the entity is an empty object. The components are those decorations that are themselves actually just data. And then you've got systems that run across all those objects and move them around. So things like detecting collisions, camera controls, all those things are just rendering systems. They're all just systems that run across all the components and update the scene. So if you think about that from a visual perspective, your entities, again, very, very simple. It's an ID with a set of components. And in this case, I'm just drawing one very, very stupid, simple component, which is to rotate. I just want to have a sphere in my scene that spins around in a circle. The way you define that is you say, my object is just an ID, then I attach a component to it, I put that behavior on the component. And even then, I break that down. I say, the rotation is actually just X, Y, and Z value, and a speed for each one, and then the system is what actually goes and looks at all the things that have that component on it, and it updates them all. And this is, the system component is running at every frame, every 60 times a second, and it's just updating everything. Now, for simplicity, we tend to compress the component system together. It's just that's just again, there's a religious debate here whether they should separate them or keep them together. Practically speaking, most people put them together. But again, it's very simple. Your entities, and they have components on them. And you're going to see that in any game engine you look at, and so it's worth just kind of getting that picture. This is Play Canvas. If you guys have ever seen Play Canvas, a really awesome open source WebGL HTML5 game engine. This is their scripting system with components. So again, you've got an object. Script and component are pretty much interchangeable. You've got a component. The component initializes and it updates. So when you write code, you write your code in an update loop. And of course, obviously, your updates can be set up initially. So very, very simple and really, really powerful once you start using it. Second thing, I'm going to show you this one using a live demo of a tool from 3JS. So again, this is so simple, it's almost difficult for me to show you, but it's so. So I've got an object, and I'm going to add another object, and I'm going to add another object. Okay. So typical 3D scene, you know, kind of the basic controls here. Now the way that, okay, like I've got a bunch of objects, and the way we tend to organize objects is through a scene hierarchy. And you can see here it's all really flat. I've got the scene contains the circle, the sphere, the sprite, and the box. But I can start moving these things around. So I can say, for example, the box, I can move its parent to, instead of being parent by the scene, I parent that to the sphere. And now what's powerful is that now if I move the sphere, things move together. And so, again, there's not a whole lot more that I want to show you, but than that. But if you put this scene graph concept together with your component system concept, now you can start doing things like attaching components to the parent and then those apply to the child. And so, okay, like super simple, but if I sort of look at what this looks like, you know, the code for this scene now has an object hierarchy. And you've got objects with children and children with children. And you take these two things together, again, I only have a few minutes, so I won't, you know, it's not like there's limitations on what I can do. But when you think about 3D space and you think about building 3D applications, this is a really powerful way to start organizing your objects that pretty much everybody does. Okay. Now the last thing is, I'm going to jump into a barrel for this one. Is I know that 3D objects get really scared and people worry about how they're made, so I'm just going to do a quick primer on what 3D assets look like. So this is a 3D model of a zombie, obviously, and so this is where the zombie comes from. So the zombie starts like by an artist who creates this in a tool like Maya or 3D Max. Basically a sculpting package. So just like you have a 2D, like a Photoshop, think of this as like Photoshop in 3D space. And you build these really kind of, well, it's kind of not ugly, but somewhat elegant geometry for the object. Relatively small number of polygons, a small amount of data. So each point here is actually an actual, you know, think of this as like a row of data, like an Excel spreadsheet saying, here's all the objects in the space and how they connect together. So that's my 3D data. Now, the artist who's made this model, that's the geometry alone isn't getting me this final object. So where is that final object coming from? The final look of this is coming partly from the visual diffuse texture, which that's what color the model is. So I've got a diffuse texture down here somewhere, so you can see, you know, the different parts of the model are just basically attached onto the model. Basically provide the colors. But there's actually a little bit more than that, because it's not the same. If I look at, say, his head here, it's not simply that this kind of ugly-looking, chunky geometry is colored. There's actually more to it. Somehow there's fine detail being added. And that fine detail comes from this other technique called normal map, which tells the system, so fundamentally what we're doing is every frame we're creating a flat image out of the data that's provided to us. And what this normal map is doing is it's telling us how to reflect light off that model. So you'll notice here we've got some fine detail. I think it's like if it's black, then there's no light. So a crack in the surface would just be black. Light doesn't reflect off that, so it gives you that appearance of a fine crack when there's actually no detail there. It's literally just an image. Show you that image. It's just an image telling you how to reflect light off the surface. And so you put all these things together. And you've got the geometry that is just basically thinking about it as a spreadsheet of data. You've got the normals, which is an image that layers on top of that to provide fine detail. You've got the diffuse texture, which tells you what colors the model should be. And then you've finally got lighting. In this scene, we've got a bunch of different lights. We've got ambient light, and main light, and fill light, which provide, lights have colors, and they affect what they look at. And so that gives you the final look of the asset. So, I'm not going to disambiguate how you actually create this content. You still need an artist and a professional to go and make this stuff. But in terms of what you're actually getting, and as a developer, what you're going to be working with as you use this kind of content in your applications, you're going to be provided with geometry, you're going to be provided with images, And I guess the last thing, as I'll show you, you're also provided with this model and some animation data as well. So let me just add the animation. And I'm not paying attention to my 5 minutes. Is that the first time I'm getting that? Or? Okay, cool. I can kind of talk all day about this stuff. So that's animation data. And the animation runs on the graphics card as well. So this whole scene is being rendered, and it's possible because of WebGL. And like I said at the beginning, WebGL is essentially a JavaScript API that gives you as a developer access to the graphics card. Now you're probably not going to start writing graphics code, but you can use a tool like this, or like FreeJS, or PlayCanvas, or one of the other WebGL rendering tools to build, whatever application it is you want. If you like to build more gaming kind of stuff, you can do this. There's tons of other things you can build with this same kind of tool set. But we're able to do this because of the graphics card. My CPU is not doing anything right now. The animation data is running on the graphics card. The geometry is rendered in the graphics card. It's all been offloaded. And I can do lots of cool stuff. So that was my 5-minute warning, and I got a few more minutes. I'm just going to show you a couple more examples. I can't see you. Okay. Because I don't want to give you the example of this all about guys getting kicked in the nuts and zombies. There's real stuff you can build here as well. Like if you do any kind of e-commerce, think about kind of the next generation of a shopping experience where you're browsing products and configuring your products. You can get super high quality renders really fast. So this is the Amazon Echo, which is a really cool product in its own right. But yeah, so basic animation. Unlike video, which is a sit-back experience, and you just sit and wait for it to go. This combines the two. You can have guided experiences with some cinematic effects, but then you can also give the user the ability to step in and control. So that mix of content is really powerful for products, really powerful for new media, really powerful for education. Our biggest market is, and I'm not going to talk about BrightLane too much, but our biggest market is in education. That's surprisingly where the most interest in this technology has come from. Because if you're a course developer, you want stuff that looks like apps, but you don't want to deploy apps. It's brutal. It's time-consuming, and so if you can spin up something like this really quick using JavaScript and HTML, and you can load it, use your analytics and your existing tools, then it's much more powerful. So that's my 15-minute or so spiel. Other questions? Does that make sense?
You have one example of shoes there. From sort of like an e-commerce perspective, like it's a really cool feature from a user's perspective. Is there anything that could really like speed up and even cheap to like create these models of like existing career products?
Yeah, so it is a good question. So content is the biggest challenge, the cost of content. So in order to get somebody, that shoe was made by, because I know the guy who made it. It was made by taking a 3D scan of the shoe and then touching it up in a tool. So you're talking about, like $150 or $200 per shoe. So it's not something, at the moment, it's not something you want to do for your Zappos. Until scanning gets better, which is, let's say it's, a couple of years away. At a certain point, at a certain point, the cost of scanning will come down so far that Amazon will have scanners in their warehouse, and every product that comes through will be scanned, and it will just be seamless. Because the scanning technology is also improving really fast. But as of today, and I should also mention, something like shoes is easy. It's a nice, like rough surface. Things that are shiny or transparent, those are really hard to scan. The shoe is kind of it's a nice example for us.
Well, one of my clients is a shoe company.
Yeah, no, so what I would suggest is for flagship shoes, like promotion, this is the perfect thing to do something around a few category leaders. But in terms of getting every shoe, that's probably a year or two away. I have to look here first.
You might have to part of the question, but sort of content creation.
Yeah, we actually have a research project with Seneca right now that's looking at using GIS data.
Yeah, because that's how you get the cost on the actual pretty mapping, area mapping. It is traditional coming down, so.
This kind of ties into over there. Have you considered maybe
Sure.
approaching, for example, Nike, asking them to import their products? Marketing tool?
Yeah, so like we're a 10-person startup, so we have limited bandwidth. So Nike hasn't done much yet. Adidas has done some WebGL work, and I know the guys who've done that with them. I mean, our focus, as a small company, we focus primarily on education. We do a little bit of product marketing. We've done some, we've actually done a couple of interactive movie trailers, one with Amazon for Earth Echo, and one with the Hallmark Channel for the Christmas movie. So we've done a little bit of product marketing, but yeah, so a company like Nike, absolutely. When you look at that shoe model, it's a matter of time, and their catalogs are all going to be like that. The challenge, which I didn't sort of mention, was we depend on WebGL, and WebGL has only been on iOS for the last 6 months, and it's only on iOS 8. So for a big company like Nike, and actually Nike has a WebGL shoe demo out there. I forget who made it, but there actually is and I won't look it up now, but they have done a project in this, and it is the way e-commerce is going to look. Hard surface models are easy. Like IKEA right now, 90% of their content is 3D models in all their catalogs. Everything except things like cushions and soft sofas. Everything hard surface is 3D models and synthetic photography. And it's, they're already working towards interactive 3D on their website. And yeah, so that stuff will be first. The harder stuff is the shiny, everybody wants cars. Every agency I talk to says, I want to do everybody, Audi, BMW. When can we do an interactive car configure? No, those are really, really hard. Shininess, transparent surfaces are really hard to do in 3D. But everything else, anything hard surface, shoes, those kind of products will be really soon. Yeah.
You said it's hard to simulate shines. Is it because it doesn't support specular map, or is it the parts?
So we have specular maps. It's the level of detail, and our chairman, every time somebody comes to us and asks for a car, I always want to do it. We have some models of cars that are beautiful. It's not going to be good enough. There's always, the way he says it is, there's always going to be some guy in a ponytail who makes your life hell. And so yeah, we just, it will happen. We have full physically based rendering in our engine. We have specular maps. We can make things look really good. It's not as good as offline rendered photo. It's just the quality's not quite there for that super high-end product. Yeah.
In terms of performance, is there an existing game or application that you can benchmark WebGL to? Can it do Quake, or can it do the original Doom?
Yeah.
Because I played with it a little bit and had some moving parts and just cranked it up to 100,000, and my browser went and crashed. And it'd be cool to see if there was an application or a game that you'd say, okay, now WebGL can do this. Right. And then as processor power gets higher, we can now do this.
Yeah, I don't have a perfect answer to that. I'll tell you the main bottlenecks. So the biggest bottlenecks on rendering right now is JavaScript performance. So anything with a lot of physics or anything with a lot of objects that have to move around the screen, your JavaScript performance is going to cause a problem. The second thing, in terms of lots of objects, if you have a game with thousands of objects on the screen, that's not going to work very well right now. We have WebGL is based on OpenGL ES2, and we get hardware instancing OpenGL ES3, which lets you put a lot more objects on the screen. And so, and you just work down the list. So you got a bunch of all the different, and this is also the challenge of WebGL, is it's no longer you write it once and it works and everything with HTML. You now have to be aware of the different devices you're You could build something that runs beautifully on your MacBook Pro, or just even better on a gaming machine. You put it on a phone and it sucks. You put it on a MacBook Air, it sucks. You have to be able to, you have to design it to run on the specific hardware. But things like WebGL 2, which is coming later this year, gives us instancing that lets us put a lot more objects in the scene. The other limitations, the amount of geometry will affect the performance. Number of meshes affects performance. Textures, yeah, not a good answer, but there's just a lot of variables. Everything's moving fast. Hardware's getting faster. You know, WebGL spec itself is improving. But in terms of graphics performance, I think you'd be surprised. Even on a really, like we did a project with Kindle last year. Even on their $80 tablet, we had we had 4 3D scans of the actors from this movie animated, and it ran fine. So as long as there's not a lot of JavaScript, rendering is solid. Yeah.
Cool, thank you.
Yeah.
Is there like, do you foresee there being any like language wars like there were like OpenGL and DirectX in web space at least in the near future?
I don't think so. I think everyone is. So we have Angle for DirectX. Yeah, it's a good question. I don't think so. I mean, everybody was surprised. Everybody was waiting for Apple to get on board with WebGL and see whether they would do it, and they did. So it looks like, from web developers' perspective, WebGL is the answer.
I don't remember. The last I heard about iOS and 3D was that they came up with their own 3D language as well, like for Volt or something. Swift, yeah.
Yeah, but that's for the native side.
Okay.
But they do have WebGL support. Across the board, everybody has WebGL support now. So, you know, there will be, I won't say wars, but there will be, you know, 3JS is the leading open source rendering engine today. And there's a couple of game engines, like Play Canvas has one, there's a couple of others out there. And so in terms of what you guys use as developers, I think that's an open question. And that's a moving target. You have lots of different options for different kinds of applications. You know, we provide one with, you know, a particular focus, not quite a full game engine, but towards more interactive presentations. You're going to find a suite of these middleware tools coming in, which is great, but there's going to be a shaking up that happens there. But the WebGL spec itself that's on its own like path of evolving, and it seems like across the board it's the way to go. Yes.
Back to the challenges of certification of content, especially talking about products and cars and things like that. How much harder would it be for human form? Is that like another generation beyond that? And the related question is, if you look back in history, you see the adult industry is thriving. You know, and the adaptation of e-commerce, of video, of establishment of formats, and all kinds of things. Do you see that becoming relevant to establishing
Yeah, I mean, our funding precludes us from getting into that business. We have Ontario government funding. But you know, just to show you, so that, you know, this is a 3D scan. Human form is actually easier. So we can make realistic looking skin. I mean, it's something like this is a scan, so you've got the actual photographic textures. So yeah, you can make human form, and you can do that pretty well. The question of the adult industry, I think, you know, that's going to, you know, a lot of that's going to drive the VR, and we haven't talked about VR at all, but virtual reality, augmented reality, that's a huge space that this all plays into. Like in the near term, VR is going to be mostly game engines, but as you think about applying VR to the enterprise, so somebody like Pearson Education is a big client of ours. Pearson's prototyping with game engines, but for them to deploy apps based on building games in a game engine and deploying it to the App Store, that's a model that doesn't make any sense for a company at that scale. They're going to, you know, in order for VR to work for them, they're going to have to be able to deliver over the web, something like this. And VR on the web, and VR in general, I think the near term is primarily driven by the adult industry. At least from what I mean, I was down at the Oculus Connect conference last fall, and everybody was talking about adult. It's like, it seemed like that's what everybody was there for. I maybe that's just my bias, because it's just like, you hear this stuff and you think, what's going on here? And everybody else is staying quiet, but there certainly seems to be a lot of momentum around helping to read VR. This will all be recorded, right? Did I answer the question?
Yeah.
Okay. Any other questions?
How well does this technology support 3D printers? Can we go to white printers,
Yeah, I would say that they're complementary technologies. Pretty much everything that I'm showing you here can be 3D printed. You know,
so far, it seems like it has to print something like assembly and so on. So in this case, like, I mean, is that the same as these bodies have the standards such that it's accepted from that country?
yeah, I mean, it's a good question. So I haven't done a lot of 3D printing, but you run into issues like wall thickness has to be, correct, or it will, and weight distribution has to be correct, or it will fall down. So we definitely need better tools for preparing models for 3D printing. It's a complementary area to what we do. I actually think it's a lot more exciting to make stuff, make digital assets out of 3D objects than it is to make 3D print. I think 3D printing will be really great once we get to the point where you can, say, manufacture car parts and like industrial applications. But for trinkets at home, I think it's much more exciting that you can just make stuff. Like the fact that digital tools for creation are getting so easy to scan objects and make them, that you can then take that content and build fun applications out of it. Are you saying you can download a model for 3D printing yourself?
Yeah, it's like you kind of pull like a capital print somewhere, and
Oh, I see.
and then you can like print out those samples.
Yeah, no, that kind of thing is definitely going to start happening more. Sorry? Oh yeah, I mean, sorry, I missed that part. There is a site called. There are sites like Thingiverse. The other big one is called GrabCAD. So a place like Thingiverse, this is tons of 3D objects to print. So you can find pretty much any printable object here. And then if you're interested more in the CAD space, there's a community site here. So there are these marketplaces that are starting to emerge with 3D content in them. Great.
Thank you very much, Russ.